So today we looked at graphing polynomials. So there's some things that we need to look at when we have, f of x equals some. We need to look at our highest exponent. Okay, so say our highest exponent was 4, and then it goes down from there, right? We need to look at this highest exponent, just for example, okay? So if our highest exponent is odd, our graph, so this is all about our graph, right, is going to go in opposite ending directions. Okay, so if it's odd, we're going to have something that kind of looks like that, or like, that was really bad, but like that, right? They go in opposite directions, okay? So this one's down, this one's up, or up and down. If our highest exponent is even, then they're going to be going in the same ending directions. So they're either both going to be going down, or they're both going to be going up, and it can look like anything in the middle. Okay, so our highest exponent, odd, opposite. Odd, opposite. They both have O. Even, same. Okay? Next we have to look at our leading coefficient, okay? So this is the number attached to our highest exponent. Okay, so if it is positive, our right-hand side of our graph is going up. Okay, so no matter what, it can either look like this or it can look like this. We are just focused on the right-hand side of our graph, okay? And if it's negative, our right-hand side is going down. So once again, we have a graph, and it can either look like this, so it can be going in the same direction, we only care about the right, or it can look like this, going in opposite directions, but the right-hand side is going down. Okay, determining the number of zeros. Okay, so our maximum number of zeros is determined by our highest exponent, okay? Highest exponent. So if our highest exponent is x to the 9th, then the maximum number of times that our graph can cross my x-axis is 9 times. Okay, it can cross less, but the maximum number of times that it crosses is going to be 9. And then the number of curves, so the number of times that my graph curves. Okay, so this is a curve, this is a curve, this is a curve. The maximum number of times that my graph can curve is 1 less than, oh my goodness, the highest exponent. Okay, so if I have 9 zeros, then I'm going to have 8 curves. If I have 3 zeros, then I'm going to have 2 curves. Okay, so it's 1 less than the number of zeros. And then your y-intercept, so where my graph crosses my y-axis, is my constant. So say that it crosses at +4, I'll have f of x equals, this would be negative x squared, right, plus 4. So my constant is my y-intercept. Okay. So looking at this example, what we need to determine is basically we just need to look at our leading coefficient. That's going to tell us what's going on, right? So we see this 9 here. This 9 is telling us that my graph is going in opposite directions at the end. Okay, because it's odd. All right. This negative here is telling me that my right-hand side is going down. Okay. So if they're going in opposite directions and my right-hand side is going down, then my left-hand side has to be going up. Right? This 9 is also the max number of zeros that we can have. All right, and then this +2 is my y-intercept, and that's all that we have to look at. So we can either have a graph that, let's see, 1, 2, 3, oh, let's extend this a little bit. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So my right hand side is going down. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 9 zeros, 9 zeros. My right hand side is going down, which is what we need. My left hand side is going up because they're opposite. Okay, and so my graph can either look like this or it can literally look like this. Okay, so this 9 is not saying I have to have 9 zeros. It's just saying that the maximum number that I can have is 9. So this also works, right? Okay, looking at an example like this. So the first thing that we have to do with an example like this is rewrite it with my highest degree coming first. Okay, that is standard form. Okay, so in your book it's going to say, or on your worksheet that you have today, it's going to say rewrite in standard form. So you just need to rewrite it highest to lowest degree. Okay. Oh, and also this is at y equals 2, and let's pretend that this was over here at y equals 2 for my y-intercept. Okay. All right, so for this, we have a positive leading coefficient, positive leading coefficient. So we know that my right-hand side is increasing or going up. We have an even degree. So my both sides are the same. Okay, and negative 12 is my y-intercept. Okay, 6 is my max number of zeros. So we can have a graph that looks like, let's see, negative 12, let's say, and it's going to, let's just do this to start. My right hand side is going up, both sides are going up, so 1, 2, 3, 4, 5, 6. Okay, so here I have 6 zeros, and I have 1, 2, 3, 4, 5 curves. One less, oh, I'm not even on the page. One less than my number of zeros, and they are both going up, both sides, right? Because I have a leading coefficient that is positive, and I have an even degree, which means my right hand side is going up, which means both are going up since they do the same thing. Or I can even have something that looks like this. Okay, that makes sense also. They're both increasing. My right hand side is going up. I have a y-intercept at -12, and I have 2 zeros. Okay, so that's still less than 6, right? So we just care about my leading coefficient being positive, so my right hand side is going up, and I have an even degree, so they're doing the same thing. Lastly is end behavior. So end behavior is looking at the endpoints, not endpoints, but so this is continuing forever. Let me redraw this a little bit. This is continuing forever. This is continuing forever. Okay, so looking at number 1, the way that we write, ignore this homework, this is not your homework. The way that we write end behavior is as negative. So as we move in the negative direction, okay, on my x-axis, okay, so we're getting to negative x and positive x, right? So as we go negative, as x is approaching negative infinity, what is f of x doing? Well, f of x is going up, right? It's somewhat like domain and range. So as I move in more negative, my f of x is going up. So as x approaches negative infinity, f of x is approaching positive infinity. So as I get more negative on my x-axis, my function is going to increase forever. Okay, going this way, when x is approaching positive infinity, my f of x, my graph, is approaching negative infinity. So as I'm moving this way on my graph, my f of x is decreasing forever. And this is our form of how we're going to write that. Okay, so for this one, as we move in the negative direction, as x is approaching negative infinity, my graph, once again, my f of x is approaching positive infinity. It's going up forever. Then as we move in this direction, as x is approaching positive infinity, it's going in the positive direction forever. My f of x, my function, my graph is going up forever, so it is also approaching positive infinity.